Did you ever wonder why objects slow down and then stop after they are given a push? This glider stops very quickly after it is sent sliding along the track. But when the glider is floated on a cushion of air, friction is nearly eliminated. Now the moving glider slows down only gradually.
Static friction between this wooden block and the table keeps the block from moving until it is pulled by a sufficiently large force. We'll use a spring scale to measure the force required to overcome the force of friction and move the block. In this case, the force is approximately 23 newtons. The force needed to slide the block along the table at a constant speed is less than 23 newtons. The coefficient of kinetic friction is lower than the coefficient of static friction.
Any two objects being rubbed together have frictional forces between them. How do those forces depend on the area of contact between the objects? We'll use this long board and a spring scale to find out. If we pull the board along the table with its widest face down, the amount of force required to overcome static friction is about 12 newtons. If we now tip the board up on its edge so that the surface area in contact with the table is decreased about 4 times, how much force will be needed to move the board? The force remains about the same. To a good approximation, static frictional force does not depend on the area of contact. How does the friction between two objects change as the force pushing them together is increased? We'll use this long board, a spring scale, and some weights to find out. If we pull on the board with the spring scale, we will notice that the board always starts to slide at about the same force. This is the maximum value of static friction. If we add enough weight to the board to double the overall weight, how will the required force change? The force needed to move the board approximately doubles. If we now add another weight equal to the weight of the board, tripling the original weight, we see that the force is approximately tripled.
This incline has 4 different surface materials: rubber, wood, sandpaper, and Teflon. Identical brass blocks are placed on the 4 surfaces. Now the board will be tilted until each of the blocks starts to slide down. As the board is tilted, the blocks begin to slide in a definite order. We'll repeat this sequence with the angle of tilt displayed next to the board as each block slides. Here are the angles at which each of the blocks started to slide on the various surfaces.